Hello, everyone. So today we basically will learn how to basically execute a linear regression using a polyfit. Okay, so let's just start calling our libraries. Here the code will be very simple, but like for learning, let's assume we have a very long line, and you want to add some comments to track down what you have changed or what you're adding in this line. So the best thing is to add a hatch, and whatever you're writing down after this hatch, it will be not executed when you run the program. So let's call this one called the libraries. Now the first library will be numpy as an np. Then we'll be importing also the matplot library dot py plot as plt for shortcuts. So let's start basically calling the data set here. So we have the data set, and let's assume we have a series of data starting from 1 to 15. So there is a shortcut to do that in NumPy library. So np.arrange, and you always add 1 to the end of the series. So it will be adding like you're gonna be subtracted from 1. So this is from 1 to 16. Now let's assume we are in a perfect world, like where they are correlated very well, and we have basically y is 2.5 by x, but we're gonna add some noise. Okay, so we're gonna learn how to add some random variable for Python. So let's assume this is 2.5 by x. Now we're gonna add the noise here. Okay, so will be also use the NumPy library. So np.random. Okay, now it has a plenty of random distributions, such as uniform distribution, normal distribution, etc. So let's call the normal distribution. And I think you remember the normal distribution is bell shape with mean and standard deviation. Like for simplicity, let's assume that your noise is between -1 and 1, and with basically a mean of 0 and standard deviation of 1. Then you will want to add basically the length of this matrix. So the size of it will be equals, it will be the same as x, so len length of x, so len of x. Now we have the data prepared. Let's add the linear regression model by the polyfit. So linear regression using polyfit function. Now we know the equation for linear regression will be y equals a by x plus b. So this is basically a polynomial function with first degree, and we will call the model. So you can call it coefficients to know it's basically restricted to coefficient or model. So coefficients will be equals to, now we will do the NPy library. So NP polyfit, it will be between x and y. Now, one thing you need to add is basically the degree of polynomial. If it was linear, you will add 1. If it's square, meaning parabola, you'll a2, whereas the equation will be ax squared plus bx plus c. So here it will be 1. Now, we want to have the y predict. So y predict will be equal. Again, we're going to call the NP library. So poly val. And now we're going to add the model, so the coefficient, and make sure that you have added correctly. So you can copy this line here or copy this thing and put it between the coefficient and x. Now we will start having our scatter plot. So scatter diagram. Now we're gonna basically draw the original set. So this will be plt dot scatter between x and y make sure that everything is set up as you define it because it's case sensitive. And now you're gonna add label to know basically you are doing that with labels. So this is will be original data. Now we're gonna add also the predicted line here. So plt dot scatter. Now this is gonna be between x, but this time with y predict. And now we're gonna distinct its color from the previous one. So it will be color equals. So let's add red. Of course, you can add R minus, which is like meaning a dashed line, RO with dots or dash. But simply because we have here all two lines, so we can distinct them only by colors. You can add these tricks, especially when you're running like multiple algorithms and you want to know what each one. Sometimes the colors could be kind of like misleading. Now we're gonna add label again. So this is will be equals now predicted data. Finally, we will add the labels. So we have basically plt dot x label, which will be x axis, and plt dot y label with y axis. And let's see how's the plot look like. So plot dot show, and let's run the program. Okay. So when you see basically there are sometimes overlap, so the noise could be basically not that much. So let's increase the number of or like the variance here and run it and see how it look like here. Okay, so we have another scenario right now. Okay. And basically this is how it should look like. Okay. So next video we'll learn about basically how to basically train the data set and then test it and how to manage that, which is the best model through the mean square error.